Hey guys, today we're revisiting the law of sines. So you might remember this from geometry last year. But before we jump in, there's a few other things that we want to introduce to you. First of all, whenever you see this solving the triangle, it simply means that we're going to solve all the missing sides and angles of a triangle. We have enough information to do that with SOHCAHTOA, inverse SOHCAHTOA, law of sines, and law of cosines. So also, we want to introduce to you this supplements theorem. Now, because of the symmetry and the rotational symmetry of the unit circle, for all degrees, for all thetas, I should say, in degrees, the sine of theta is also equal to the sine of 180 minus theta. And then finally, here's our law of sines. It simply says in any triangle, it does not need to be a right triangle. So take note of that. You have the sine of an angle over the side across from it is equal to the sine of another angle over the side across from it, and that's equal to the sine of the third angle over the side across from that. So again, keep in mind here that it's always this relationship. The sine of an angle over the side across is proportional to the sine of an angle over the side across from it. Now, this will work for us when we have these given situations, when we have an angle, angle, side, angle. We're going to look to use the law of sines in order to find the remaining lengths or angle measures in that triangle. All right, so let's jump in with example 1, in which we're going to put to practice here this supplements theorem. It says find all the solutions to sine theta equals 0.528 in the interval of 0 to 180. Now remember, sine theta is your y values here. So which theta is going to give us a y value of 0.528? Well, we're going to take the inverse sine of 0.528 to find out what angle measure this is equal to. When we do that on our calculators, we're going to come up with 31.8 degrees. Now on our unit circle, again keep in mind here, I'm just going to sketch out this unit circle here. 31.8 degrees is about right here. So this y value is going to have the same as this y value over here, which now we need to find out what this angle measure is. And we can do that by using this supplements theorem. So that's 180 minus 31.8. And when we do that, we get degrees of 148.2. Now, we should confirm that the sine of 148.2 is approximately 0.528. Okay, now you see that we took the sine of 148.2 and we do get, in fact, 0.526, which is what we were hoping to get. All right, now it says find all solutions of sine theta that are equal to 0.78. So again, we're going to do the same thing here. Take the inverse sine of 0.788. When we do that on our calculators, we get 52 degrees. Now, which other theta between 0 and 180 will give me a sine of 0.778 or 0.788. We can get that by taking 180 and subtracting 52. When we do that, we're going to end up with 128 degrees. So 128 degrees will also give me a sine of 0.788. All right, let's jump into example 2, where we're going to apply our law of sines. So it says two forest rangers are in their stations, S and T, and they are 18 miles apart. On a certain day, the ranger S sees a forest fire at F, so we'll make a little fire here, at an angle of 42 degrees with the segment ST. The ranger at T sees the same fire at an angle of 74 with ST. Find the distance from the station T to the fire. So you can see here, this is the side of the triangle that we want to find. So we have this idea of angle, side, angle. However, we're missing this angle up here at F. Now, keep in mind from geometry, the three angles of a triangle add up to equal 180. So we can find the measure of angle F simply by adding 42 and 74. That's going to give us our 116 and taking that away from 180 to get that remaining amount. When we do that, you should end up with 64, I believe. There you go, 64 degrees. Now we can set up the law of sines. So our law of sines should read the sine of an angle over the side across from it should be proportional to the sine of another angle over the side across from it. So we'll set up sine 64 over 18 is proportional to the sine 42 over x. Now we have a proportion which we can cross multiply x times sine 64 is equal to 18 times sine 42. I got one more step because I want to get x by itself. I need to divide both sides, by sine 64. When I divide this side by sine 64, this all becomes a calculator problem now, and I'll be left with the value of x. So let's go to our graphing calculator, and we will type in 18 times our sine of 42 degrees. We're going to close up our parentheses now, and then divide that by sine 64. And when we do that, you see that we get 13.4. So x is equal to 13.4, and this in units is going to be in miles. All right, let's take another look here at using the law of sines, and now we're going to use that law of sines to find the measure of an angle. We simply want to find the measure of angle Q. Well, here's angle Q. If I take a look, I know the side across from it is 6. I also have another relationship here, angle P, and the side across from it. So we have this situation in which we have an angle side. So we're going to take this sine of 51 degrees over the side across from it, which is 8. And now I'm going to take the sine of angle Q, which is my variable, that's my unknown, and set it equal to set it over the side across from it, which is 6. So again, I have two ratios set equal to each other. It's a proportion. I'm going to cross multiply by simply multiplying my 6 out here and my 6 over to that side. Now I have sine Q is equal to 6 times sine 51, all divided by 8. Well, remember, I need to get Q by itself, so I got to get rid of this sine. In order to get rid of sines, I need to take the sine inverse. And that's what I'm going to do. I'm going to take the sine inverse of both sides, and that will leave me with the measure of angle Q. So angle Q is going to be equal to the inverse sine of 6 times sine 51 divided by 8. Now again, this just becomes a calculator problem. So I'll slide this over here, and I'll take second function sine, there's my inverse sine, of 6 times sine 51, close up my parentheses, divide by 8, close up my parentheses again, and I can press enter, and I'll get my 35.6 degrees. Alright, so there's an example of using the law of sines to find both a measure of an angle and the length of a side. Let's try one more example here together. It says in triangle TRI, R measures 25, angle I is 72, and TI is 13. So take a second to draw out that triangle, what you think that looks like. Just kind of give it a rough little estimate here. Here's R, here's T, here's I. Angle R is 25 degrees, angle I is 72, which means the remaining measure for angle T should be 83. We also know that TI is 13, and RI is what we want to find. So we'll call that X. So again, here we have a situation where we can use our law of sines. So we'll set up the sine of angle 25 over the side across from it is proportional to the sine of 83 over the side across from it. When we do our cross multiplication and division here, we're going to multiply both sides by x and x. Let's start that over. We're not going to multiply both sides by x and x on this one. What we're going to do is we're going to cross multiply. So we got our x times sine 25, that's what I meant to say, is equal to 13 times sine 83. Oh boy. And now we're going to divide by sine 25. Okay, so once we divide off that sine 25, that's when we'll be left with x. So x will equal 13 times sine 83, all divided by sine 25. Go ahead and plug that into your calculator, and you should end up with 30.5 is the length of segment RI.